Hello to all of you and welcome back to my SV2 channel. So this video is all about the atomic and ionic radii. We're going to be looking at both of these concepts with respect to their periodic trends as well, and we also have a practice for you at the end. Okay, so starting by atomic radii. So if you remember from the quantum mechanical model, right, we said that the atoms do not have sharply defined boundaries where the electron distributions becomes exactly zero, right? However, we can still think about different ways that we can, define the atomic or even the, ionic size, right? So there are going to be a couple of terms that I want you to kind of pay attention and try to remember them. The first one is a non-bonding atomic radii or radius, also known as van der Waals radius, right? And that is the distance from the nucleus to the outermost electron cloud in a non-bonding interaction, right? And it typically goes by the shortest distance between nuclei during the atomic collisions, okay? Then I have the bonding atomic radius, also known as covalent radius, and this will be the bond distance, right, which is d, between the two covalently bonded atoms in a molecule, which is smaller than the non-bonding atomic radius, right? And that is primarily because of the attractions that we have between the two atoms that are holding them together in our covalent bonding, right? So here's a simple picture. Bear with me. Looking at here. So this will be the distance between the nucleus and the outermost electron in your electron cloud, which is presenting your non-bonding atomic radius. And here is the distance from one nucleus to another one in a covalently bonded molecule, right? That is our D, right? And then if you take half of that, right, 1 over 2 D, that will be our bonding atomic radius. Okay, cool. Okay, so looking at the periodic trends in atomic radii, if we are moving in a column or in a group from top to the bottom, then the bonding atomic radius increases, and that is mainly because of the increase in the principal quantum number, which is the n, which means that we are placing our electrons farther from the nucleus, right? So that's how we can understand that the size is getting larger. But if you're moving from the left to the right side within a period, then the bonding atomic radius are generally decreases, and that is mainly because of the increase in our effective nuclear charge, right, which is the topic that we have talked about it in our previous lecture, right? So this would be, a stronger pull on the valence electrons, and therefore they're going to get closer to the nucleus. You can look at this picture. This is just the kind of overall presentation of all the elements that we have on the table. As you can see, from left to right, we're typically getting smaller, and from top to the bottom, we're getting larger. Okay. Okay, the next topic is going to be our ionic radii. Okay, that means either we have a cation or we have an anion. Starting by the cation, where we have positive charges, these are going to be smaller than their neutral atoms, right? So what happened here is we lost an electron, and therefore the remaining electrons are going to experience a greater effective nuclear charge, right? And are going to pull closer to the nucleus. And that's why they're going to be smaller, right? Now, here's an example. We have sodium, right, Na+, which is going to be much smaller than sodium, right, the atomic sodium, because it lost the outermost electron shell. Now, if I have an anion, which is negatively charged, they're going to be larger than their neutral atoms, right? So what happened here is we gain an electron, right, at least. So electron-electron repulsions are going to increase, and therefore we are expecting to get reducing of Z effective, causing the cloud of electron to expand. And the best example that I have for you is chloride. So chloride is going to be larger than chlorine, right? Because we have the extra electron, which is causing, stronger repulsion between the electrons. Okay. Okay, now we're going to be looking at the periodic trends in our ionic radii. Okay, so if you're moving from the top to the bottom, down a column or a group, the ionic radius is going to increase just like what we had for the atomic radius for the exact same reasoning, right? So the principal quantum number is going up as you go down a group, and therefore we are expecting to get expansion, right? And therefore larger size for our radius. Now, if you're moving from the left to the right side, but you're staying within the same period, right? The cation size is going to decrease, right? Because we have a stronger Z effective, right? We got that. The anions are also going to decrease in their size, right? However, they're always going to be larger than the cations in the same period. Meaning that for ionic radii, we always have a sharp increase, right? When you are transitioning from a cation to an anion. Okay, cool, cool. Okay, so looking at the first practice, we are referring to the table. So I have a portion of the table that is needed for this question. And we'll try to arrange as much as possible the atoms B, which is boron, C, carbon, Al, aluminum, Si, which is silicon, in the order of increasing the size. And to me, it's always the best to do the comparison in pair. Okay, so starting by boron and carbon because they are on the same row, right? And we know that from left to right, the size goes down. So carbon must be smaller than boron. Then I have aluminum and silicon on the same row. So silicon would be smaller than aluminum. Then you can look at boron and aluminum, which is on the same column, right? And we know that as we go down, we get larger. So boron must be smaller than aluminum, right? And then the last one is for silicon and carbon is going to be smaller than silicon because that is on the top of your silicon, right? So put them all together on the count of 3, 2, 1. Carbon is the smallest one, and then we have boron, then we have silicon, and the largest one is going to be aluminum. I hope that makes sense to you. I have one more practice looking at the next page. Okay, so this practice is slightly different. So we have a kind of mixture of cations and the atoms, okay? So we have magnesium cation, calcium cation, right? And then calcium, just the atomic form. And we try to have the order of decreasing radius, okay? So we know that the calcium ion is going to be smaller than calcium because that's a cation. We also know that calcium would be bigger than magnesium, right? And then you can kind of put them together. Calcium is the greatest one, right? And then I have calcium cation, and then we have magnesium cation as the smallest one. Cool, cool. Okay, you know what to do, right? I don't need to say that. You already know that. But just in case, you can always give me your thumbs up. You can always subscribe if you want to learn with me a lot more. There's going to be a lot more coming up soon. Okay, take care and thank you very much for watching this video. Bye bye for now and see you soon on the next one.